Okay, let's have a look at numbers and math operations in Python. The first thing to say here is that Python defines four numerical types. They are integer, float, long, and complex. The complex and long types are usually used in advanced math operations and are not of great interest for our networking needs. Instead, we will work a lot with integers and floating point numbers, and that's why we will focus on these two numerical types and their corresponding operators and functions. So let's define a variable and assign it an integer and another variable associated with a float. By the way, the float type refers to real numbers having a decimal point written in between the integer part and the fractional part. Okay, so let's get to work. Let's say num1 is equal to 10 and num2 is equal to 2.5. So we have an integer and a floating point number. Let's use the type function to confirm this. So type of num1 is indeed an integer. Type of num2 is indeed a float. Okay, now let's see some operations we are able to do using integers and float numbers. Let's start with addition. So 1 plus 2 equals 3. Let's see subtraction. 3 minus 1 equals 2. Okay. Now division. 4 divided by 2 is 2. Okay. Let's see multiplication. 3 times 7 is 21. Okay. Let's see the raising to a power. So 4 raised to the power of 2 gives us 16. Okay. Notice that for raising to a power you have to use double asterisk. Okay. Now let's have a look at the modulo operation. This means finding out the remainder after division of one number by another. So let's say 5. The percent sign is the sign used for the modulo operation. So 5 modulo 2 gives us 1 because 5 divided by 2 equals 2 and a remainder of 1. Okay, now let's see some comparison operators. So we can compare 4 to 5. So 4 less than 5, which is true. 5 greater than 4, which is also true. 4 is less than or equal to 5, true. 5 is greater than or equal to 4, also true. We can also verify equality by using the double equal sign. So 5 equals 5, true. And we can also verify that a number is not equal to another number. So 4 is different from 5, which is true. Okay, now let's go back for a moment to the division operation and assume that we are not dividing two numbers for which the division result is an integer. So let's divide 3 by 2. Usually if you divide 3 by 2, the result will be 1.5, which is a floating point number. Let's see this in Python. So 3 divided by 2, okay, it gives us 1. Why is the result 1? Wouldn't 1.5 be the correct answer? Well, you are correct, but Python version 2 rounds down to the nearest integer when the result is a float. So, to get the correct result, you should add a 0.0 either to the numerator or to the denominator of the fraction. So Python will return a float as a result. So, if we divide 3 by 2.0, which is a floating point number, Python will return the correct result, which is 1.5. This is valid the other way around too. So 3.0 divided by 2, it also gives us 1.5. Okay, now let's talk a bit about the order of evaluation for these operators inside the mathematical expression. What if we have to deal with multiple operators? Well, the order is the following. Raising to a power has the highest priority in an expression. This means it will be evaluated first. Then we have multiplication, division, and modulo with equal priorities. And last we have addition and subtraction also with equal priorities. Let's see an example. Let's say we have 100 minus 5 raised to the power of 2 divided by 5 times 2. What would be the correct result here? Well, Python will first evaluate 5 raised to the power of 2, which is 25. Then, since division and multiplication have the same priorities, they will be evaluated from left to right. So 25 divided by 5 will give us 5. Times 2 will give us 10. And finally, subtraction, having the lowest priority, will be evaluated last. So we will have 100 minus 10 from here will be equal to 90. So let's check this. Okay, correct. Now let's look at two number type conversions. Let's see how can we convert an integer to a float and vice versa. Well, Python has two functions for these operations. Let's see them. First, we have the int function. So let's type int of 1.5. It will give us 1 because it will round down to the nearest integer. Now let's test this the other way around. Float of 2 will give us 2.0. It will add the 0.0, converting 2 to a float number. Finally, let's look at a few more functions which may come in handy in the future. First, the absolute value. This is the distance between the number in the parentheses and 0. The function for this is called ABS. So ABS of 5 will give us 5 because 5 is 5 units away from 0. This is also true for ABS of minus 5. The result is the same because minus 5 it is also 5 units away from 0. Okay, now comparing two numbers, finding the largest or the smallest one. Well, Python gives us two functions for this as well. First we have the max function. So max, open and close parentheses, and in between the parentheses we must type the two numbers we are comparing. So let's say 1 and 2 separated by comma. It will give us 2 because 2 is the largest number inside the parentheses. Also we have the min function. So min of 1 and 2 gives us 1 as expected. Finally, I will show you another way of raising to a power. It is by using the POW function in Python. So POW of 3 and 2 in between parentheses, where 3 is the base and 2 is the exponent or power. So it should give us 3 to the power of 2. It should be 9. So, okay, it is correct. I think this should be more than enough math for our networking tasks, so let's move on to booleans.